Hey YouTube, this is The Art of Prepping. Just going to talk about some very basic radio communications theory, especially about line of sight. Line of sight though is basically from the point A to point B in a straight line. And this is important for radio types of theories because there's a lot of frequency bands like UHF and VHF and SHF that require more of a line of sight because they're more dependent on that straight line of transmission. And they don't have the ability to curve around the Earth or bounce off the iosphere like other lower frequencies. So with that being said, though, I just have a couple examples here to give you a better idea of what I'm talking about, especially if we use the horizon line as that point of reference. So when we're talking about line of sight for radio transmissions, it's from whatever elevation that you're at personally up against and to the horizon line. And so the horizon line, for example, can be calculated. Let's just say that you're on a beach and you're at sea level and you're facing the actual the horizon line where the sun is setting and where the curvature of the Earth is. If your eye level is, and you're looking at about 5 feet 7 inches, and you're looking at the horizon line, it's approximately 2.9 miles to the horizon, just to give you an idea. And if, let's say you turned around and you walked up this little hill, and you're at a higher elevation, now you're at 32 feet. At 32 feet from sea level, you can actually see the horizon. Out to the horizon is now a whopping 19 miles. Let's also say that you want to double that. All you have to do is double your original elevation. So there was 32 feet. If you want to double the 19 miles to 38 miles, you just simply go from 32 feet to 64 feet. So that's kind of how it works with radio towers. Depending on how far you want to transmit line of sight with UHF, VHF, and SHF, and even some microwave technologies, you'd have to have more line of sight because materials like houses, trees, buildings can absorb or reflect your signal and reduce its actual length of transmission. So I hope this helps. I know this was a quick little primer, but this just kind of gives you an idea though of why that there are towers that are so tall, for example, and why some towers are not so tall because maybe they don't have the need to reach out so far. Thanks again, and catch us on the next one. The next part's going to be about what is RF radiation. Thanks a lot.